Hi everyone, we're starting lesson number 19 where we're talking about where functions meet, and we're going to learn how to do this both algebraically and with our calculator, and it's exercise 14H from our textbook. So the first thing we're going to look at is that if we consider the graphs of a quadratic function and a linear function, for example, on the same set of axes, we could have certain or several possibilities going on. So we could have a linear equation that will cross the parabola at 2 points. We can have the parabola crossing or touching the linear equation at 1 point, or we can not having touching it at all. So the parabola never touches the line or the linear equation. So we're looking at three situations where we would have 3 points of intersection, which would be cutting the parabola, and it would be two solutions. We would have one solution where we are touching the graph, and that would be 1 point of intersection, and then there would be no solution where it's missing altogether, and that would be no points of intersection. Alright, so let's get started right on a question. Let's take a look at a situation where we're not looking at a quadratic, but we're looking at a rational function or an inverse function. So it says, if two graphs meet, then we can solve for the points of intersection by using simultaneous equations. Alright, so given the problem, we have that if y equals 2 over x and y is equal to x minus 1, we can find the points of intersection or solutions to these graphs. Now the one way that we can go about doing this is definitely by simply using simultaneous equations. Now simultaneous equations means that we could use either substitution or elimination, and because both of these equations have y already isolated for, then what I would do is I would make the two equations equal to each other, and in this way we're getting rid of the y so that we can solve for x. So that I would start off by saying then that 2 over x is equal to x minus 1. And then I would cross multiply here, so I would have 2 is equal to x times x minus 1, which tells me that 2 is equal to x squared minus x. And then I would bring everything over to one side of the equation, so that I have 0 is equal to x squared minus x minus 2. Now, as because I've set this equal to 0, then what I'm going to do is I'm going to factorize this. I'm going to solve for x, and I can use the sum and product here so that I know that either x minus 2 or x plus 1 must equal 0, and therefore using the null factor law, we know automatically that x minus 2 is either equal to 0 or x minus x plus 1 is equal to 0. Therefore, we know that x is either equal to 2 or x is equal to negative 1. Now, if we assume that x is equal to 2, then we substitute that into either equation above to get our corresponding value of y. So that I will say y is equal to x minus 1, y is equal to 2 minus 1, which equals 1. Therefore, our point of intersection, our first point of intersection, will be found at x equaling 2 and y equaling 1. Now, if I take x equaling negative 1, then I can insert that again inside the equation. So I'm going to substitute that into the equation, into either equation. However, I'm going to again choose to place it. So by substituting again into either equation, then I will substitute again into y is equal to x minus 1, so that y is equal to negative 1 minus 1, which makes it negative 2. Therefore, I know that my second point of intersection then is found at negative 1 and negative 2. Okay. If we want to do the next one, we could try to do another example. And by doing another example, again, we're going to isolate for y, which is already done here in both equations, so that I could say that 3 over x is equal to 2x minus 1, so that this will become 3 is equal to 2x squared minus x, and that 0 is equal to 2x squared minus x minus 3. So here we're going to have to split the middle term so that we are looking for two numbers that multiplied together give me negative 6, and the same two numbers added together give me negative 1. So I can safely assume that it's going to be 2x squared, and then it will be minus or plus 2x minus 3x minus 3. So the two numbers are going to be negative 3 and positive 2. So I split the middle term now, or in other words, I group here. I do some regrouping with the four terms, and I remove 2x, and I'm left with an x plus 1 minus 3 times x plus 1, so that I know that either x plus 1 or 2x minus 3 are my factors, so that x is either equal to negative 1 or x is equal to 3/2. Now, if x is equal to negative 1, then that means that substituting into either of the equations, then I can say that y is equal to 3 over negative 1, which turns it into negative 3. Therefore, our point would be negative 1, negative 3 would be our first point. And then we can do the same thing where we substitute y equaling 3 over 2, so that y would equal 3 over 3 over 2, which automatically would make it to 2 over 9. And therefore, y equals 2 over 9. And how did we get that? I did 3 divided by 3/2, which then gives me 3 times 2/3, and no, it doesn't give me 2 over 9, but it just gives me 2. I jumped the gun here, so that it equals 2, my answer. So that our final answer then would be 2, and therefore we know that when x is equal to 3 over 2, or 1.5, our value of y is equal to 2. Okay, now what I'd like to do next is very quickly is I'd like to try doing one of these problems, or possibly two, by using the graphics calculator, the GDC. So given the point y is equal to x squared plus 3x plus 1, or not the point, but the equation, x squared plus 3x plus 1, and y equaling 2x plus 2, what I'm going to do is I'm going to bring up the calculator, and what we're going to try to do is we are going to graph the two situations. Alright, so starting with the first one, I go to the plot, and I do x squared plus 3x, and then plus 1, and there's my first equation, and my second equation to graph would be 2x plus 2. And now I'm going to press enter again, and I'm going to go straight to graph. This may or may not work automatically. I might have to change the window, but let's take a look first to see if I need to change the window in any way or form. So there's our there's our parabola, and now let's see what happens with our equation of the linear equation. And our linear equation seems to have two separate points in which we can it has two separate points that we can isolate for, that we can figure out. So it's crossing at two places. So what we do next is we will go to the second function calculate button, and I'm going to go to the number 5. And number 5, as you can see, is the intersection point. And what you're going to see here is that you have a flashing button. You have the flashing cursor here, which is showing me that it's on one of the curves. So right now, if I move this back and forth, I see that it is on the parabola. So the calculator is asking me if my first curve is the parabola. And so I press enter, and I say yes. At this point, the cursor has now moved to the other graph, which is the linear equation, and again, it's close by to the point of intersection, and it's asking me again now at this point, what is my second curve? Is my second curve the linear equation? I'm going to say yes to that because it is close enough to the point of intersection without actually touching the curve. And then I press, afterwards it says if I want to take a guess. Because I do want to take a guess of what the point of intersection is, I then press enter again, and I end up getting these points for x and y. Now, the point asked us to put this to, if I'm not mistaken, to 2 decimal places. So to do to 2 decimal places, that means that my first point would be 0.62 for x, and for y it would be 3.2. So I would do 0.62, therefore it would be 0.62, and then my next point would be at 3.2, and therefore my y value is at 3.2. Let's try doing now another example, and I think I'm going to pick D, and let's see what happens there. So on D, we are going to do just this last question on D, and I'm just going to clear everything. So I'm going to get rid of all of my graphs. So I'm clearing everything, and I'm going to go back to the plot, and I just want to clear here the clear press history, so that I'm going to now place in the equation. So I'm now going to graph y is equal to, so I'll place x squared minus 1, and then I'm going to place in there x raised to the power of 3. So that's x cubed. And I'm going to go to graph. Let's see if that's going to be sufficient for me to see the x cubed graph along with the x squared minus 1 graph. Let's see where the x cubed graph is. So the x cubed graph, now what I'm going to do is, because I can't see very well where the points of intersection are, I'm going to show you a new technique where we can actually make a zoom box. So I'll go to zoom 1, and what I'm going to do is I'm going to move my point left and right. So these are, I'm going to zoom in into the area. So I'm just going to keep moving the cursor. Okay, and I think that's good enough. And I'm going to now press, oops, I think I went a little too far. Let's go a little bit further back, or closer into the graph. And I'm going to press enter. And the moment I press enter, that creates, it's creating a zoom box, so that I am going to get into the area and zoom in into the area that I want to get into. So I'm getting there. It's taking a second here. It's a bit slow, but it's getting there. Okay, so I just kept that pressed, and now I'm just going to move my way down until I can see all the, I get into the area that I want to see. Okay, so there. I would say that would count, that would be a perfect place to go and to finish it off. And then I press enter, and there it is, that it's giving me, very slowly, but it's giving me the points of intersection so that I can see them zoomed in a little bit more clearly. So it seems to be crossing only at one point in this particular case. So now, again, I'm going to go to second function, calculate, and I'm going to go to the number 5. And again, it's already on the graph, so I have this already on the graph here. So I'm going to press enter. So I've gotten on one graph. Now it's asking me for the second curve, and the second curve seems to be, now you can actually see it, but I'm going to put it just a little bit more where it's a little more visible. Oops. Okay, so I'm going to put it right there. So that would be fine. And then I'm going to press, again, all I did was use the arrow buttons up and down, as you can see. You can see that from the press history. And then I'm going to press second curve is enter. Do I want to take a guess? The answer is yes. And my point is 0.75, or rather negative 0.75 and negative 0.3. Therefore, it's negative 0.75 and negative 0.43. And again, these were all done to 2 decimal places. Okay, so I've shown you basically how to find the points of intersection between 2 graphs, and it's not necessarily going to be 2 linear equations anymore, but it could be a linear equation and a quadratic, or a linear equation and a rational function, or it could be a quadratic and a linear. It could be numerous things, the types of graphs. But the way we do it is to set them equal to each other, or by using simultaneous equations, or the alternative would be to use the calculator and place the equations in the calculator and then find the points of intersection. Okay, that's it. I'll see you next time.